Dear viewers, everyone has its favorite pet and its favorite design pattern. My favorite design pattern is the proxy pattern we talked about in episode 4, I think. However, there is this active object pattern I consider very cool. Well, the active object pattern is very much based on the command pattern. It has only one method called run, and all it has to do is run each command it has in a linked list. In case you missed our previous episode, a command pattern is consisted of an interface having an execute method. Each object implementing this interface will be executable by a client. So, if our client is an active object class and we call run on it, it will execute all the commands it knows about. Assume we will implement a solution to upload multiple files. To do this, we will have a multi-file uploader class, which will use uploader commands and upload the files. We will not effectively implement the upload in this example, we will just simulate the transfer of chunks of data. Let's start with a simple unit test to exemplify what are we going to achieve. Let's say that our test will check if the multi-file uploader can upload multiple files. We will start by creating an object of the multi-uploader. We also have to be sure that all required classes are loaded. Our test is in a tests folder, so when we require the files, we have to go one folder up. Next, let's define some variables we will assume for our transfer, as speed, let's say 8, it doesn't matter what 8 represents at this point, and a size of 50. Then let's define our first uploader. The new uploader will be initialized with the speed and size variables. We will use this uploader inside a multi-uploader class. So we will add it to the multi-uploader. We have to make sure that we are in a test, so I forget to add the extends PHP unit framework test case. Then we will run our test again. And we can see that we have an error that the add uploader method is missing on the multi-file uploader class. Let's jump to that class, the multi-file uploader, and implement the add uploader. The method will have a parameter of type uploader command. The class will keep an array of all the added uploaders. Adding an uploader will simply push the new value at the end of the list. Now, if we run our test, you can see it passes. However, it does not do anything much right now. To make it complete, we will add another uploader and use it in the same multi-uploader class. But let's say this uploader uploads only at a speed of 4 and has a size of only 20. We will call it uploader2 and add it to the uploader, to the multi-uploader. Okay, this will still pass our tests. But actually we are not testing anything yet, we are just making sure that our code is correct. The next logical step would be to call the run method on our multi-uploader, exactly as you saw it in the UML schema. Our multi-uploader is in fact the active object and it will have a run method. Multi-uploader will be called with run. Okay. This will fail because we don't have a run method yet, but we will write one in a moment. The run method will simply iterate over each element of the uploader's array. Then it will call the execute method on each uploader. In order for this to work, we have to create an uploader command. The uploader command will have the function called execute as defined in the command pattern. Also, our uploader command will have a constructor which will populate two variables, size and chunk, and also will define the uploaded variable. We have to specify the two parameters also, speed and size. Then, size will be passed to our internal variable, and chunk will be computed from speed and size. We will use this variable to specify a size that will be uploaded on each run of the execute method. Imagine this as our command would be executed in each second, and the speed of upload would be 8 kilobytes per second. Then a chunk of 8 kilobytes would be uploaded each second. But to not complicate our solution, we will just assume that our chunk is the size per speed. And at each call, we will upload the equivalent of the chunk in size. Our execute will keep the uploaded size so far. So it will update the uploaded private variable each time with our chunk. Also, I will print this information so we can see it. If we would run our test now, it would fail because I missed to specify this in the multi-file uploader. However, that being fixed, it should be all okay, and if we look at the output, we see that two values were printed. It seems like my coding of the new line is also miscoded. Let's just fix that too. In the uploader command, when we put a new line, we will use double quotes. That's it. Run the test again, check the output, and you can see that we have two runs, one for each command. The first is 6.25 per 50. That would be the first command having a speed of 8 and a size of 50. The second is 5 per 20. That would be our second uploader, having a speed of 4, yes, and a size of 20. Well, so far, nothing special. But what would happen if each of these commands would have a reference to the multi-uploader and put themselves back in the chain, back in the list of commands, and do this until there is nothing more to upload? Wait a minute. Isn't that, in fact, a simple implementation of multitasking? Let's see. The uploader command will have a reference to the multi-uploader, and we will use this command, as you can see in the test, by adding the multi-uploader as the third parameter. If we run this, it still passes, we introduced no errors. However, the output is still the same. Only one execution for each command. Let's go back to command and keep the reference of our multi-uploader in a private variable. Doing so allows us to call the add uploader on the multi-uploader like this. And instead of adding another command, we'll just add ourselves. We have to go in the multi-uploader and modify our for each. Instead of using for each, we will change it into a while statement and execute it as long as our uploaders list is not empty. Also, we will have to take care about the shifting of the array. So if instead of directly executing the uploader, we first have to obtain it. The uploader will be obtained by array shift on our internal private uploaders array. Array shift returns the first element in an array and then removes it from the array. So be very careful whenever you use the array shift command. Then we can call on our uploader the execute method. If I would to run this command now, it would never finish, because our uploaders array would never be empty. Remember, uploader command puts itself back in the array. So let's just not run our command and get a very ugly error. Instead, make sure that we add ourselves back in the chain only if the uploaded size is less than our real size. So, if uploaded is less than size, then add ourselves back to multi-uploaders list, otherwise we will just return from execute and the execution will break. Now, if we run this, you can see there are no errors, the execution stopped, and something interesting happened. The upload was not sequential. It wasn't the first command executing until it finished and then the second continued. On the other hand, each command executed a little bit, and then another little bit, until one of them, the one having the size only 20, finished. As you can see, there is a 20/20 line printed here. After that, the uploader having the size 20 did not run anymore. So, only the uploader having the size of 50 continued to put itself back to the list and finished its job at some point. In fact, what you see here is a very simple implementation of multitasking, an implementation you can still find in many older applications. This was common practice 10 or 20 years ago. Today it is cool. Not widely used, but it is cool. Still, if you are thinking about transaction, when you will have a series of commands you have to execute at once, the active object pattern can be of great use. That would be all for today. See you next time when we will talk about another interesting design pattern.